All right, well, thanks again for joining us today for the topic of Ansible Network AI Ops and taking a look at various aspects of AI and how different ideas of how we might implement some of them into the network automation space. So I mentioned before the recording that there's a demo today. The demo will primarily be around the network AI ops and specifically around Ansible and some of the components of the Ansible automation platform to include Lightspeed, where we're going to talk about some other topics, but those would be really good candidates for future demos. So we'll kind of unpack that a little bit more as we go through. But today there's only so much time, so we're just kind of in that crawl, walk mode, crawl, walk, run mode. So we're kind of at the crawl stage. And then over a period of time, I'll introduce other topics that are more specific and we'll zero in more on some of the specific things that we talk about today. So for the agenda, we'll take a look at some high-level AI terms as it pertains to network automation. So this is not an exhaustive list of all the things that you can do across IT with AI. It's primarily things that I think are interesting that can help network engineers. Since this is Ansible for networking, everything's kind of through the lens of a network engineer. And then we're going to double click into what we can do today around AI ops, specifically with network use cases and using some of the capabilities that Red Hat provides directly in the Ansible automation platform, some things that you can do more directly from like a playbook, and some of the other components in the platform and things outside the platform, like OpenShift AI and things that are starting to evolve and come together quite nicely to kind of bring us into this whole world of agentic AI. And we'll talk a little bit more about what that means. So if you're not like real advanced in AI, which I myself, I'm kind of a little bit of a novice in this area. There's a lot of moving parts. So again, it's kind of so broad that I'm really just trying to look at it more, how it could benefit some of the network use cases. So that's the gist of this session. So first, let's kind of talk about, high level, some things and kind of build like a framework of things that we can, again, double click into more later. So one of the high level notions here is around the model context protocol servers and how they're helping us, because this is giving us as network engineers and as automators a way to interact with these MCP servers in a way that we receive immediate value or immediate answers to our questions. And a lot of that is around the notion of, like, analogy to this is like a notepad. Right. So if we ask a question, to AI, to an AI agent, to a chatbot, all sorts of different ways that we can have a conversational experience, through prompts, we're able to, have access to, in this case, a large document or like a large LLM that has a lot of information, right, that we only have to have access to in that pool of information once. And then we're able to send, multiple questions and build, on top of what we're prompting for, right? So as we interact with it, we can sort of refine the way that we're asking for information from AI. And if we're building something, let's say like in a network space, we might start out more general and then we refine our questions until we're trying to build something very specific, like mapping to a use case. And two things like come to mind for me is as a network engineer and as an automator, sometimes I'm trying to either remember best practices or I'm trying to learn new things from like a networking perspective. So there's a lot of network knowledge base that I need access to kind of on the front end, just to understand the intent of what I'm trying to build, but actually, like, what am I building on the back end? Is it based off of the vendor's best practices, their validated designs, those kind of things? And then once I feel comfortable that I'm building the thing the correct way, I'm starting to create a wrapper of automation around that. And there's a lot of constructs and things and expertise that takes time to build on the automation side. So it's kind of like layers of knowledge where, from an Ansible side of things, learning playbooks, learning how to optimize your playbooks for performance and to organize them better into roles. And then from that, taking advantage of like the automation platform to create orchestration through workflows and all of the subcomponents that and requirements and dependencies you have to build in order to create a workflow. So things like the inventories, the projects, the job templates, all of those things or those components take time, and they also take a level of expertise. So there is somewhat a barrier to entry to an extent of do I have the knowledge across all of that, the thing I'm building and the process through automation. So with AI, we can simplify a lot of that. And that doesn't mean to say that a subject matter expert doesn't need to know these things, but as using it as an assistant, it makes it a lot easier, a lot quicker. We can move a lot faster to create those constructs. So we're going to try to connect the dots between the network and the actual automation and kind of connecting that together through AI. So the MCP server, what's important there, and I kind of went off a little bit of a tangent to like kind of reach that panacea of more help, more assistance around building networks and automating the networks. It's becoming a lot easier because we're starting to see these protocols, or these standards rather, that create like a blueprint of how we can use MCP, the Model Context Protocol. So that way we don't have to deal, or we don't have to know low level know as much around the commands that we need to integrate with LLMs. We kind of use this standard way, so that in my mind it's very similar to how we create a standard way of dealing with like a vendor solution through APIs. So if I'm automating something, and if it's, let's say Cisco as an example, like DNA Center, it has its REST APIs, but typically I'm not interacting directly with those REST APIs. I'm not making, or at least I shouldn't have to make all of the REST API calls and understand, if I want a particular parameter, I'm going to have to, if I want to configure something, I have to create a post REST API call with a data payload that, includes content, for that specific configuration. With Ansible, we have these collections of modules, right? So that abstracts all the complexity, and it's handling those parameters for us on the front end. It's very simple. We're defining those parameters in a playbook, in a YAML file. And then when we run that playbook on the back end, there's a Python script that's actually set to send the very specific REST API call, to that, in this case, like DNA or Catalyst Center, rather, for the current name. So that abstracts a lot of complexity. So that's what's happening here is with MCP, we don't have to know as many low-level details, to interact with all these different models that we have available, these open source models, as well as some of the more purpose-built vendor models that are out there. So having said that, it's kind of like a lot of what we've learned, with automation and orchestration and workflows, is starting to make its way into like this AI world, where we're beginning to have access to the APIs of the other tools that we're using in automation. So the access to the APIs of your automation controller, access to APIs to your network vendor solutions, to where it's not just an LLM, a knowledge base of how to do things. It's actually what is the current state of the configuration in your environment. So from an Ansible perspective, like what's actually there already, the inventories, job templates, workflows, how can we, create new constructs with what you already have, leveraging, your specific environment. So that kind of takes us to this slide, right? So, for a long time, we've been able to prompt and ask, how to create a playbook, give it requirements. You can even like prompt it further, like use resource modules versus Jinja 2 templates and config modules and those types of things, and get a really good answer, for like a playbook. And then taking that like a step further and building, like take your playbook and convert it into a role, but to go to that next step to like, hey, actually build, use that content, but now build all the constructs in my AAP environment and build, a workflow around a use case that's network specific around my actual, network devices. So that's where this whole agentic AI thing is taking us, because it's giving us a way to declare a config and how we want to automate it and those types of things so that we can achieve a specific goal. So this means that, the capabilities are extended, directly to, like I mentioned, our environment through the APIs. So we're working from, again, a specific situation as opposed to more of a conceptual viewpoint of like, how would you apply a certain thing? This is how would you apply it, directly in my environment. So this is something that like Red Hat in particular is moving in this direction, and a lot of the other vendors are as well, is giving you a way to allow for the AI to have, more ability to plan, reason, and execute independently with minimal human intervention, because you always, or at least for some time, right, you want either policy as code or some human in the loop to kind of put the guardrails around your AI, or at least, from a security perspective and from like a quota perspective of not building, going crazy and building too many instances of whatever it is and those types of things. So this will evolve over time, but having, access, to the environments, that's where the agentic AI is taking us. And then it can make, recommendations of what we need to do to configure our, our specific environment. In this case, AAP in like a Cisco or some other vendor's network, as an example. So what Red Hat's doing is they've got, different products. They're kind of moving across a lot of overlap in these different areas. But the thing that I'm going to talk about today in the demo is the Ansible Lightspeed, but not leveraging it from the VS Code directly. So that's the coding assistant. I'm going to access the API of the Lightspeed service. And I'll kind of table that because I'm going to show that a little bit clearer in the next slide or so. But I'm taking advantage of being able to orchestrate a workflow and have a playbook prompt directly to the model that I want to work with, as opposed to this coding assistant, which I would use that directly in my VS Code. So if I'm building a playbook, help me build this playbook, here's the requirements. That's the perfect use case for the coding assistant. The intelligent assistant is fairly new, and it's a tech preview going into 2.6 as the GA, where it's available actually in your UI of the Ansible automation platform. So it will help, solve things that you're trying to configure in the platform and help you, manage the platform easier and things like that. So it'll be, embedded into like your specific AAP. But we're kind of talking about more like a future looking into things that I want to be able to do, like combining like the network with the AAP. That's more around the AI orchestration. So that's going to give us the ability to create not automation workflows, but AI workflows. So that way, there's a particular logic in how we want to deal with all these different models and CP servers. We can orchestrate between that. And that's something that, again, like on the other slide, it'll show you other products like the like OpenShift AI and things like that that can give you like an environment that does all these things. But more importantly, like what we're talking about today is the AI ops. So the AI powered IT operations, as it's depicted here. Those are things we can do today because Ansible Automation Platform has the event-driven Ansible. It makes it very easy for us to be able to couple that together with Lightspeed to do things like ticket enrichment, where we're going to, determine problems more proactively, collect data and glean, the actual root cause of particular issues, and to triage that into tickets, right? So that way, when a network operator opens up a ticket, a lot of work has already been done for them to save them time from a troubleshooting perspective. And that's what the demo is going to focus on, a big piece of that here soon. The other part is self-healing infrastructure. So again, EDA is, really the focal point there as well, but that's with the ability of being able to make changes in real time to correct issues in the network infrastructure. So that's where, we've been very cautious, like leading up to this point, because we need more around decision point the process to approve these types of changes, because when we go into production, especially with network infrastructure, we can't just go willy-nilly and reconfigure devices. So we have to be very specific in what we're changing, and integrations back into change management and ITSMs and all that kind of stuff. So there's a lot of closed loop, operational closed loop types of process that needs to be orchestrated around that. And then just being able to do more in IT operations in general will provide cost and resource optimization. We kind of hook this into our insights, which is like a Red Hat analytical service that makes recommendations primarily around servers, but that can be extended into other areas where it's providing you with more insights, more actionable intelligence through analytics and through AI. So those are kind of like the different categories of things that kind of land in different products. But here's like more of a double click into that, especially for like what I'm talking about today. So if we look at an AI client, or what this says or depicted here as an MCP client, we can have access to a lot of different models. The one that primarily that when we talk about Lightspeed, although it can connect to like these other other open source sources as well, it's primarily the service is around the IBM Granite LLMs, which are a knowledge base that goes very deep into Ansible, right? So best practices around content, but also best practices around the automation platform. So managing it, managing like the system itself, lifecycle management, but also managing the automation and different controller as code types of things that you'll build in that regard. It knows how to do all those things. So today, Lightspeed is very good at, like I mentioned earlier, creating content if I want to help, building playbooks, roles. And then with the MCP, like moving forward to the MCP server and the hooks into the APIs of Ansible automation platform, and also the event-driven Ansible that we just alluded to, having direct access to that, then we can have the ability to make configurations directly into those constructs on the fly. So build me a playbook and roles, update the repo, but also create the workflow and all of those requirements or dependencies that a workflow has. So inventory and anything else, any extra variables, all the things that you need could potentially be built for you in this particular use case, right? So this is again more from like the automation side of it. So this has the assumption that we already know what we're building, right? So we already know what type of network we're building, EVPN, VXLAN, or an MPLS network. We already have configurations. Now turn those into what we need to automate it and do that for us, and assist us with that particular task. Going beyond that, outside of the realm of those specific Red Hat models, or the the IBM Granite models, we can also hook into these open source models. So with the Llama having the ability to prompt that LLM for like basic networking configurations, you can do a lot of that in this open source model. So in this particular example, it's create a new VLAN with ID 100 and name it guest. So it can just give us right away what's the ILS configuration for that. And then specifically, if it were Nexus OS, we would ask for that. It would look a little bit different, similar, but there's going to be the nuances. And of course, vendors' command lines are a little bit different. But it can give us these answers back that we can take and should test them, right? Since the sources for this aren't like a prescriptive vendor knowledge base. If you want to go like to that next step, something that's really interesting to me that was announced at Cisco Live a couple months ago in San Diego was the Cisco Deep Network model. So you can think of that as a model that was built around like the troubleshooting aspects were built around like TAC cases and that knowledge base. It has a lot of knowledge based off of the CCIE programs. So all sorts of different scenarios and best practices on how you should build, specific types of networks and architectures, with this very purpose-built model, right? That gives you, a huge data set of network knowledge. This is something that's being, I think it's like an early adopter type of thing with a trial of some CCIEs are using it, but over time, it's going to be made available to like all CCIEs, and it'll become, productized that you can use with the Cisco AI assistant to be able to ask it questions, more advanced things, not just like, how do you configure VLANs, but how do you configure like this entire solution, right? This, build me this ACI fabric. What would it look like? All the configs. So the reason why I bring these up is we'll have the ability to tap into these LLMs, as we're creating, a workflow, leveraging these capabilities to ask it, what should the configs look like? What are the prescriptive configs for the type of environment that we're building on the network side? And then overlay what we need from an automation perspective, from playbooks, roles to workflows, and kind of, bring all that together, where I think that brings, huge value. Not to say that people don't know how to do these things, but it's a lot. Like, not one person really typically knows all these things. Or if they do, it's hard to sustain that, right? Because we're working on different things all the time. So it helps us kind of bring things together much quicker without having to need as many subject matter experts in their field, to kind of like, create a way to bring all these silos of different pieces of this together. So having said that, we'll kind of switch gears to like the things that I'm talking about today, kind of the easier stuff, right? So we're still kind of crawling, is unlocking the network AIOps with event-driven Ansible. And Lightspeed, right? So those are the two pieces that are important here. So with event-driven Ansible, if you're not familiar with that, it's sort of like an opposite paradigm to what you're typically used to when you think of Ansible playbooks or Ansible automation platform. Mostly we're running a playbook either manually or we're scheduling it in the platform to run as a single playbook through a job template or through a series of playbooks or a series of job templates through a workflow, but it's being initiated, manually, right? Either a person is driving that, or through the workflow, or through a webhook trigger, some other application can trigger a workflow or a job template to launch in the automation controller. Event-driven Ansible is sort of the opposite of that, in the sense that it's always sitting there and listening. And based off of the source plugin, which there's a handful of different source plugins, but normally you're either talking about 9 times out of 10 with a webhook or Kafka buses, something along those lines, where it's either waiting for a webhook on a particular port or it's waiting for a topic to come in on a Kafka message bus. And if it sees that come in, it'll evaluate the data and make a decision. So decisions are made based off of conditionals. So if it sees something in that data that is indicative of a rule that was presented in a rule book, and you can think of a rule book much like a playbook. It's written in YAML. The difference is that it focuses not on plays and tests, but on sources. So what do you want to listen to, the webhook or Kafka or one of the other sources, and then the actual rules. So rules is where we set the conditions to say, if we see this thing and that thing together, then that would trigger an action. So what are the actions? The actions could be something as simple as printing on the screen, or sending a notification, or having a trigger to a job template or a workflow in the Ansible automation controller to run a playbook or a series of playbooks in a workflow to either remediate something or to do some automated troubleshooting. We're going to do the automated troubleshooting today, and we're also going to open and close tickets. So that gives us, a bit of that, ticket triage that we looked at earlier. But it gives us, a lot of capabilities to stitch together some of the operational tools that we already have and create this operational feedback loop where we can learn that something is down and then act on it. But we never lose that ability to have a human in the loop, because in the workflow, we can always incorporate an approval node where somebody has to, take a look at what's going on and then give the thumbs up to actually make the change. And you'll see that in the demo as well. So what this is kind of a walkthrough of the demo, but it's a little bit different, the scenario, but it's giving us, a little bit of, something to set the stage before I go in to the demo. So if we look at what's going on here, you can see that there's a Cisco network device, right? So a Cisco router, and we have an automation controller here. And as I build this out, you can also see that I have my syslogs set up to go to Splunk. So Splunk has visibility into changes in different, logging traps that are set in the Cisco network device, right? So Splunk or syslogs is really just one way to learn the operational state of what's going on with routers. Another example that you'll see in here that as we build these slides out, talks to as well, is being able to use streaming telemetry. So that's another way. So something changes, you could send a syslog, you could send either through GNMI or gRPC to streaming telemetry to a collector. You could communicate that way. And then there's, you can poll SNMP. There's, many different ways to see like what is that operational state of the router. But what's important here is that something's changed, right? So if something changes, then that could be, in this case, indicative of an error, so that event takes place on the router. So what happens from that is Splunk is receiving this data. You can set up alerts in Splunk that have, different notification options to where one of those is a webhook. Another one is to integrate with a Kafka bus. And there's a source validated content source plugin that's available now directly in Splunk. So there's like a section in Splunk, to make the configurations to integrate with the Ansible event-driven Ansible controller, right? So they've made it easier, like to do that integration, right? So something happens, we want to send a webhook, or we want to start to send data on a Kafka topic for that particular event, right? So I'm using a webhook in the demo. So in this case, the automation from the event-driven Ansible trigger would be sent from, obviously that's managed from the automation controller, which is a part of the Ansible automation platform, right? So here is just like an example of a rulebook. And this is one that I used in the past for a no shut type of scenario where it's called Don't Shut My Ports on the YouTube video. And really all this was is if I had a list of protected ports that should never go down. So these could be ports that are like, for my OSPF adjacencies and my BGP peers. If those go down, I'm okay with the self-healing because they shouldn't go down. So if they go down, I might, go into a mode with a playbook of automated troubleshooting to say, check to make sure that it's not administratively shut down, see if the line protocol is down, do some checks, additional checks. And then once we determine what we think it is, then we can, run a task in the playbook to like no shut the port or, no shut to reset the port, whatever we need to do or what we think we need to do as part of that process. So what happened in this one is you can see that we're using the source as Kafka. So the topic is called Telegraph, right? And this is just the IP address of where the Kafka is running. And we're using port 9092, which is like the default Kafka port. So anytime a port gets shut down, the streaming telemetry from the router is being sent to a collector, and the collector that's called Telegraph, right? That's what we just named the topic, Telegraph. It'll convert it into JSON data, and then the output goes into this Kafka. So the source plugin will have that JSON data, so we can parse through that JSON data. So what we care about is the state of the interface, and in this case, if it's down, right? So that's what the condition is for this rule. So if we have a down port, what we want to do is we want to look and see the name of the interface and also the name of the router. And then we can check against the list to see if that port on that router is a protected port or not. If it is protected, we want to do a no shut. If it's not protected, we'll just leave it alone because it doesn't warrant like the self-healing, right? So only self-healed ports are the ones that are on a protected list. So that's a part of what that scenario is. So once we determine, okay, that's a protected port, then we can move forward and open up a ticket to say, hey, we have a protected port that went down. In this case, it's really for informational purposes to track it because we're going to fix it, right? So it's going to be open ticket and then a closed ticket. And I'm going to do that in the demo as well. And a lot of that is just so we can track like how long was it down and what was the source of the issue, the root cause. And then all of that is like triage data that is now historically collected in ServiceNow as part of that incident or that ticket that was open and closed. And then here in number 5 is something new, right? Because what we used to have to do is we needed to know the automation up front. So based off of a condition, we would map it to a playbook, and the playbook would have some module that we needed to use to resolve the issue, depending on the issue that was triggered from that particular condition. So here we can ask Lightspeed, hey, this is what happened, through a prompt. This is what happened. Build me a playbook to remediate this. So you'll see that I have a prompt that kind of leads me to a playbook that I still need to test out, but it should work to resolve the problem. So in my workflow, I have like a human in the loop so that they can look at the results of running the playbook in check mode. If you run a playbook in check mode, it doesn't actually apply the change, but it gives you a way to kind of dry run that playbook and make sure that it's doing the things the way that you think it should be done before you run it in run mode, and it'll actually apply that change to the device. So in this case, we went right to remediate the issue because it's just the whole deal with the shut, no shut. So, no worries about the self-healing part of it, where it's a no to go in production with things that that might not be that cut and dry, right? So we want that approver to like review it and make sure we're good. And that's basically what you're going to see in this demo.